Welcome to section 4.3. Let me remind you of what we're doing. We're solving second order, linear, homogeneous, meaning equal 0, DEs with constant coefficients, meaning the coefficients A, B, and C are constants. They're not variables. Last time we saw that we could solve these equations by writing down the characteristic equation, which uses the coefficients of the derivatives of y as the coefficients of the powers of r, solving that characteristic equation and looking at the roots. And what we did last time was we did the case where we had two distinct real roots, r1 and r2, and we wrote down the general solution, and we'll do a review of that today, and a repeat real root, in which case we take e to the rt as one solution and then te to the rt as our second solution. Today, we're going to look at the case where we have complex roots that look like r equal alpha plus I beta. In that case, our general solution is C1 e to the alpha t cos beta t plus C2 e to the alpha t sine beta t. And that's because our fundamental set is e to the alpha t cosine beta t, e to the alpha t sine beta t. So let's just jump in and see what we need to know. You don't have to know a lot about complex numbers to do this. You need to know two things. One, what is I? I is the square root of -1. Two, complex solutions will come in pairs, and they'll always look like alpha plus I beta, or alpha plus beta I. Some people like to put the I after the beta. It doesn't really matter. So let me show you how this works. Suppose we want to solve the quadratic equation r squared plus 2r plus 2 equals 0. So we try and factor it, and we don't get much luck, so we go ahead and we use the quadratic formula, which I've written down for your convenience. All right, so in this case, we're going to get r equals b is 2, so -2 plus or minus the square root of b squared, that's 4, minus 4ac. 4 times 2 is 8 over 2a. A is 1. So this is over 2. So that's -2 plus or minus the square root of -4 over 2. Now, -4 is 4 times -1. So it's the square root of -1 times the square root of 4. So that's 2i. So this is -2 plus or minus 2i over 2. And finally, divide each of these by 2 to get -1 plus or minus I. So our alpha is -1 and our beta is 1. Okay, so let's jump in and do some differential equations. Okay, so we're going to write down the general solution, and in each case we're going to state the characteristic equation. We're going to factor it if we can. If it's complex, we won't factor it. And if the roots are complex, we're going to state alpha and beta. So the characteristic equation for this first one is r squared plus r minus 2 equals 0. That factors pretty easily as r plus 2, r minus 1 equals 0. So our roots are 1 and -2. So we're starting out with a review of what we did last time. So in this case, our general solution, this is the easiest case, y equals c1 e to the t plus c2 e to the -2t. And again, the order doesn't matter. Next one, characteristic equation is r squared minus 4r plus 4 equals 0. That factors as r minus 2 quantity squared equals 0. So that's a repeat root of 2. So I'll just write 2 twice. And so in this case, my general solution, this is the second case, c1 e to the 2t, and then I multiply by t, c2t e to the 2t. Okay, next one's going to be complex. Write down the characteristic equation, r squared plus 4r plus 7 equals 0. Try and factor that for about a nanosecond and realize you can't, so we're going to bust out the quadratic formula. R is -4 plus or minus the square root of b squared, which is 16, minus 4ac, which is 28, over 2a. In this case, 2a is just 2. So that's -4 plus or minus the square root of -12 over 2, which is -4 plus or minus 2 root 3 times I, because the square root of -1 is I, all over 2. This is negative 2 plus or minus root 3i. So alpha is negative 2 and beta is root 3. That's all we need to know. Y equals C1 e to the negative 2t cosine root 3 times t plus C2 e to the negative 2t sine root 3t. So it looks scary, but it's super easy to find. Okay, next one, characteristic equation is r squared plus 16 equals 0. It does not factor as r plus 4r minus 4. Remember, a squared plus b squared does not factor. It's prime. A squared minus b squared factors as a minus b, a plus b. So this is r squared equals negative 16. Take the square root of both sides. When you take the square root of both sides, you take plus or minus. So r is plus or minus 4i. So in this case, solving a characteristic equation that looks like that is super easy. So alpha is 0 and beta is 4. That's all you need to know. And then we plug in. Y equals C1 e to the 0t is 1, so I'm not going to write down e to the 0t. Just skip that and go straight to cosine of 4t. And then C2, again, e to the 0t sine 4t. Okay, next one's a little different. Write down a DE whose solution is this. Okay, to help you do that, I'm going to do this in steps. What are the roots of the characteristic equation? That's step 1. What is the characteristic equation? That's step 2. Once we know the characteristic equation, we can write down the DE. So let's start with the roots. If the solution looks like this, we know that alpha is 0 and beta is 3. So here our roots are 0 plus or minus 3i. That's 2 roots. Okay, so the characteristic equation, again, just looking at the last example, must be r squared plus 9 equals 0. Because r is plus or minus the square root of negative 9. Okay, and finally, once we have that, we can write down the DE. So the r squared corresponds to y double prime. There's no y prime term, and the 9 corresponds to plus 9y, and that equals 0. So there's our DE. So do it in steps like that. Okay, we're at the last problem. Here we've got a cubic. Our characteristic equation will be cubic. So r cubed, here's our characteristic equation, minus 5r squared plus 6r plus 12 equals 0. Now there's 4 terms. Whenever there's 4 terms, I try factoring by grouping. But I can see that's not going to work here. So I go with my, let me find a root, so hopefully I can divide and then factor this. So the possible roots have to divide 12. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So there's a lot of them. Start with the smallest ones. So r equal 1, get 1 minus 5 plus 6 plus 12. That's 14, not 0, so that's a no. So let's try the next smallest one, which would be negative 1. We get negative 1 minus 5 minus 6 plus 12. Yes, that equals 0. So if negative 1 is a root, r minus negative 1, which is r plus 1, is a factor. So keep in mind that r equal negative 1 is a root. That's a pun. We'll factor that in later, but we'll consider that later. But right now, what we need to do is take our original characteristic equation right here, this polynomial, and divide by r plus 1. So r plus 1 goes into, that looks like a square root, but it's division, r cubed minus 5r squared plus 6r plus 12. All right, so we're going to multiply by r squared, r cubed plus r squared, subtract to get negative 6r squared and bring down the 6r. And now this goes in minus 6r times. And so we get negative 6r squared minus 6r, subtract to get positive 12r and bring down a 12. This goes in positive 12 times. 12r plus 12, remainder is 0. So our characteristic equation now looks like r plus 1 times r squared minus 6r plus 12 equals 0. We know one root is negative 1. Now we need to find the roots of this guy. So we look at it and we say, does it factor? No, it doesn't. Bust out the quadratic equation. So the quadratic equation for this guy is r equals negative b. B is negative 6, so that's 6 plus or minus the square root of b squared, which is 36, minus 4ac, 4 times 12 is 48, over 2a, which is over 2, so that's 6, plus or minus the square root of negative 12 over 2, which is 6, plus or minus 2 root 3i over 2, so that's 3 plus or minus root 3i. So my alpha is 3 and my beta is root 3. So from this, I'm going to get two terms in the general solution, and I'll also get a term from the r equals negative 1. So I'm going to write down the general solution, y equals. So for the root of negative 1, r equals negative 1, we have c1 e to the negative t. And then for these roots, I'm going to get two terms, c2 e to the 3t cos root 3t, and then c3 e to the 3t sine root 3t. All right, and that is the end of this section.